We are team 4 and now I will explain about tutorial 2. So first of all, 60 meter cube per second gas stream containing 79 mole percent of methane and 21 mole percent of carbon dioxide at 25 degrees Celsius and 100 kPa is fed into a mixing chamber. A second gas stream containing 5 mole percent of methane and the remainder carbon dioxide at 50 degrees Celsius and 150 kPa is fed into the same chamber. So we have two inputs for this chamber. To achieve the mixing target, the produced gas stream must contain a minimum of 30 mole percent of carbon dioxide. So A, draw and label the process flow diagram completely. So for the process flow diagram, there is two input and one output. So we need to know the basis by calculate the molar flow rate using PV equal to nRT. And we get PV divided by RT to get the molar flow rate. So after putting all the unknown, then we get the molar flow rate. So we get 2420.51 mole per second. After calculate the molar flow rate, we know that the basis for this process flow diagram is 2420.51 mole per second is fed into stream 1.
Now, let's see the question B. If the carbon dioxide flow rate in the second stream is 240 mol per second, can the process achieve the mixing target? Show your calculation and explain your answer. So, to meet this condition, CO2 must produce at least 30 mol per cent in stream 3. Next, for calculation, we perform the DOF analysis first. Then we got 3 unknown, N2, N3, and S, 2 material balance, CH4 and CO2, then 1 process bed. So total equals to 0 can be solved. Then we calculate the PS1. N2 times with 0.95 equals to 240. Then we got N2 equals to 252.63 mol per second. For total balance, in equals to out, N1 plus N2 equals to N3. Then we got N3 equals to 1673.14 mol per second. Next, CH4 balance, in equals to out, 0.79 times with 2420.51 plus 0.05 times 252.63 equals to 2673.14 times with X. X is the mole fraction of CH4 in stream 3. Then we got X equals to 0.72 mol per mole of CH4. Next, composition for CO2 in stream 3. 1 minus mole composition of CH4, which is 0.72. Then we got mole fraction of CO2 equals to 0.28 or 28%. Since 28% mole CO2 is less than minimum required, which is 30 mole percent of CO2, so we can say that this process can achieve the mixing target.
For question C, if the pressure of the second stream is 200 kPa instead of 150 kPa, does the process achieve the mixing target? Show the calculation to explain your answer. We have T2 is 50 degrees Celsius, P2 is 150 kPa and P2 new is 200 kPa. We use 2 because this process is happened in stream 2. First thing first, we need to find the V dot 2 using P equal to 150 kPa in S2. We are using the formula P2 V2 equal to N2 RT2. So we rearrange the formula to get V2. So the answer for the V dot 2 is 4.52 m cube per second. Next, we need to find N dot 2 new using P2 new, which is 200 kPa in stream 2. So we're using the same formula as before, which is PV equal to nRT, but we are using the value for P is 200 kPa and using the value for volume flow rate that we get before to find the new molar flow rate. After fill in the value that we already have, we can cancel some unit that can be cancelled. We get the new molar flow rate for stream 2, which is 326.63 mole per second. And now we are using the DOF analysis that we already did in question B. So at first, total balance in equal to out. And N1 plus N2 new equal to N3. We are using the N2 new that we already get in question C. So 2420.51 plus 336.63 equal to N3. And we can get the value for N3 is 2757.14 mole per second. Next is CH4 balance in equal to out. 0.79 times with 2420.51 plus with 0.05 times with 252.63 equal to X times with 2757.14. From this, we can get the X value, which is X is equal to 0.7. For composition CO2 in stream 3, we are using the composition is equal to 1 minus X. 1 minus X is 1 minus 0.7, which is we get 0.3, and we time with 100% to get the percentage of the CO2 in S3. So since we get 30 mole percentage of CO2 in S3, which is it is same value as the minimum percentage for CO2 that should be in S3. That means the process is achieve mixing target. That's all from us, Team 4. Thank you. Bye. Assalamualaikum.